Was this already due or is this due today? Okay, so this is due today. Just show of hands, how many people already finished this? So most people. So I guess I'll leave a little bit of time at the end of class if somebody has any last minute questions and needs help, but make sure to get this turned in today. Very important. Actually, so much so, let me just make sure there's an announcement. So one of the things I've done in previous semesters was, rather than having the last two assignments, having everyone do like a project, I decided not to do that this semester because I think a lot of people, what happened was a lot of people would get overly ambitious with their project and like want to write a game in Pygame or something like that. And then when it came down to it, and when you actually realize how much work it is to do that sort of thing, and you're just trying to get through the end of the semester, I would get a lot of people who, I'd get a lot of half-completed projects, let's just say that. So this semester, what I've opted to do is we'll have an assignment number 7 and 8. I would encourage, though, anybody who wants to do a project, I'd be more than happy to help you out where I can. And I don't know if I'll do extra credit. I don't know. But if anybody's interested, see me after class and doing a project. But so we're going to have an assignment number 7 and 8. Now, you've already learned the core of the language. You know the bulk of what you do on a day-to-day basis. Now, like most programming languages, Python is a gigantic language, like Java and C#. All these languages are in C++. They're huge languages. But realistically, if you learn the core, like 30% of the language, you can be very effective in that language, and you can do a lot of good things. And so that's where we sort of are at this point, where we've learned like the core 30% of the language, where you can write pretty much any program, and then that last 70% is if you're doing very, very advanced things. You need to know every corner of the language. And I'll be honest, I don't even know 100% of the language. Sometimes I'll see code that somebody wrote, and I'm like, what the heck are I doing there? And I look it up, and I'm like, oh, that's interesting. I didn't know it had that feature of the language. So really, and that's just a made-up number, by the way. We didn't learn exactly 30% of the language, but you get the idea, is that we learned the core basics of the language, and then outside of COP2030, then we learned about like lists and dictionaries. So we learned some basics about data structures. You learned some object-oriented programming, and to me, that's enough to get started. So today, what I want to do is actually start to write real-world code, not like these made-up projects that I kind of make that are very like manufactured and like you wouldn't see some of these things in a real-world system. It's because I've kind of very tailored them and manufactured them to like fit a specific need. But assignment number 7, in today's example, what you'll see is that this is much more of a real-world example. This is code I might write on a day-to-day basis. And it kind of builds on everything. So it's good. Now, I don't think I need to tell most people in this room that the web is very important. And just a quick history of the web is that when Tim Berners-Lee created the web in the late 80s, he saw it as So Tim Berners-Lee was a scientist. He was working for CERN. And he wanted basically a way of what's known as hyperlinking. Like if I've got a research document and I want to reference another document, I want to make it so that I can just click and go to that other document. And that's essentially what he was working on with the web, was this interconnected series of documents, what we now call web pages, where think of Wikipedia as an example. If I'm on Wikipedia and I see an article that's interesting, I just click that article, I go right to it. Versus like if you've ever seen a research paper, you know how they have the references at the bottom and you've got to go to some journal and look it up. So I think that's generally the direction he was going. But everything was static web pages. There were no forms to fill out. There was no interactive stuff. You couldn't really play games on it. Everything was just static web pages. It was just a piece of information. And then if I saw something interesting, I could click and go to another piece of information. Then we realized that, well, I can make this interactive. I can make it so that on that web server, I can actually run scripts. So back then, it was usually a language called Perl. It's interesting because Perl used to be really, really popular, but Python pretty much took over that area of the web. So it's really interesting. Perl was chosen because it was really, really good at text processing. And so that's what a lot of the web is, text processing. But people realized that they could run Perl scripts. And so now they started to create interactive websites where I could order a pizza online, where I could put in my address, hit submit, and then that would go to some web server and then into a database. And most people, without even thinking or realizing it, most sites these days are web applications. They're not just static information. So like your social media sites like Twitter and Facebook and stuff, but even basic stuff, like if I just want to order a pizza and I go to their website and I fill out a form, or even your student registration, these are all what's known as web applications. Now, for a very long time, probably a good 15 years, maybe even 20 years, I think we're reconnected. So what technology, and say like the last 10 years, do you think has really affected how we think about the web? What small technology that replaced many computers for a lot of people? Exactly, phones. And for most people, you do your heavy lifting, your like major apps, or your major programs. We do those in apps, not websites, but we've kind of gotten used to writing apps. Well, let's say, for example, I am Pizza Hut. Now, the process that I used to have of ordering a pizza online, that's essentially going to be the same on mobile. But what problem do I run into? Apps, you don't really write apps. I mean, you can write apps in HTML and stuff. There's ways to do it. But let's just say you're writing just plain old Objective-C or Java code. I can't. I basically end up having to write two separate systems. I have to write the website version and then the app version. Now, if I want to kind of recycle code and use it twice, what I do is I write something service. Now, web services are interesting. What web services do they are these things where I'm using the web, but I'm actually not spitting out a website. So what that usually means is that I send this thing called a web service. Remember I talked about that we have these scripts that run on the server? I'm not spitting out a web page, but what I'll spit out is usually like just raw data in a format called JSON that we'll see. But think about dictionaries and lists. That's what I'll spit out. So I won't output a web page, I'll output a dictionary and list. So how is that useful? Well, then what I can use is I can create a website that uses JavaScript that takes that data and then formats it on the screen. Does that make sense? So rather than having a web page directly interact with the server, what I do is now the server sends me back some data, and now my web page uses JavaScript to parse that data and put it on screen. But that means now I can also reuse that same code to send that code to an app. And then that app can use its own internal. It doesn't use JavaScript, it would use Java or Objective-C. So you see the difference? Rather than having to write the code twice, all I have to do is write two user interfaces. Notice the difference. Before I would have had to actually write two separate back end and front ends. But now with web services, what people typically do is they write it once and then they offer some sort of API. And so many times when you're dealing with something, let's say for example you're writing a program to deal with getting data from Twitter, what they'll do is they'll offer a web API, a web service. And so a very, very, very common task, even if you're not necessarily doing something for a website, a very common task is to what's known as consume these web services, use them. So what I'm doing is I'm writing some piece of software that connects to that server and then gets data back. So that's a long, I wanted to go through the whole history of that. That's why I'm telling you that this is a real world scenario. This is actually something we do in the real world. That's essentially what you're going to do in assignment 7. But let's kind of get into the actual coding part of it. So under resources, so I'm trying to tackle 2 things today. One is to show you that specific task, but one more very general thing is that you're going to have to start using modules and software that other people have used. You're not just going to be doing stuff in the low-level language. You're going to be using modules and reusable code that other people have written. So one of those is it's called requests. And what this is a guide for I'm reading here. It's a software library for interacting with web services, essentially. Okay. So what you'll do is you'll connect to a server, all in Python, on the command line. You'll connect to a server, and it'll give you back data. So now we're doing real-world stuff here. We're actually connecting to a server. Now, web servers, essentially we can do 2 things. We can actually do more than that, but for this class, let's just keep life simple. We'll just say 2. We can either get data from the server, or we can send data to the server. So what we call an HTTP GET request or an HTTP POST request. So we're just going to deal with gets and posts. So I'm going to either request data, get, or I'm going to send the server data, post. And so we have this library for doing that. There's actually several libraries for interacting with web servers in Python, but I like this one. I used to use one called URLlib all the time. I hated it, and so I'm glad that somebody wrote something that's better. So this is what we're going to be using here. A lot of times, personally, I don't memorize a lot of these libraries. I find myself, when I'm doing development, I have a lot of tabs open on various guides and documentation and API references and so on. If you look at an average programmer's browser, at the end of the day, it's probably full of tabs. Like, for those of you that do programming as a hobby, do you ever find yourself doing that? Like at the end of the day, your browser is full of tabs.
Stack Overflow.
Yeah, mostly Stack. Yeah, that little Stack Overflow icon. So I didn't want you to think like you memorize the core of the language, but anytime you're using libraries, a good amount of the time that you're using libraries, you're going to have to reference stuff. So I want to kind of go through a real world scenario here. So there's this nice little site here called JSON placeholder. So JSON stands for JavaScript object notation. You might ask, why do we care about this? We're not writing in JavaScript. There used to be, and there still is, a data format called XML. XML was great because it was very specific, and you could organize data into pretty much any way you wanted, and it was human readable. But it's very, very complicated. And that human readable part is in quotes. It's in English, but it's debatable whether it's actually human readable. It's not in binary code and bits, but it's definitely difficult for a lot of people to work with. So what they did is JavaScript internally has its own data format essentially, because it has the equivalent of dictionaries and lists. And as we've already learned in here, you can do a lot with just dictionaries and lists. Pretty much almost any data representation. Just with those 2 things, we can represent any type of data that we're going to work with anyway. And so what they did is, as the web got more popular, JSON kind of became this de facto standard. And it's really nice with Python because Python, it's like a direct mapping. With some other languages, you have to jump through hoops, like with Java. Working with Java and JSON isn't the most fun thing in the world. But with Python, it's great because there's a direct mapping. It has the direct equivalent of lists and the direct equivalent of dictionaries. And so what we do is when we get this JSON data format back, it actually parses it to native Python code for us. And so what they have are these dummy sites where I don't want to have to go through the whole process of setting up a web application and making a web API and all that. If I'm just learning how to consume, I'm on the client side. I want to consume a web API. They have these sites that they provide a URL, and they'll give you some data back. That way, if you're just kind of learning and you're just testing some things and you just want to put some test data inside of your web page, you can use that. So this one's pretty, I like using this one. It's called JSON placeholder. And the basic idea is that this is our URL, and so we're going to be working with the, bless you, we're going to be working with the post resource. And so to get an individual post, we just do /posts and then the ID. We're not going to, I don't know, maybe we'll get an individual. If you want to list all resources, we just do it without the button, and that gives us back a square brackets. So this is in JSON, but what do you think this will map to? What data type in Python? So the square brackets. What are we talking about when we're talking about in square brackets in Python? List. Yeah, so this will map to a list. And then this is in JavaScript, this is an object, but what do you think this will map to? Which data type in Python? Dictionary. Perfect. So we're going to have a list of dictionaries. And like I said before, we if we want to create a new post, so post meaning like a blog posting, think about it like that. Like imagine if you're doing a simple blogging site, post in that context, like a blog post. And it has a title and a body, so we can send the title and body and then the user that's making the post, and we have to use an ID. Okay, so that's the setup. Like I said, there's other ways, there's other things we can do, updates and deletes and so on, but let's just keep it simple. So knowing that this is what we're going to use, we're going to deal with this site, and using this guide, let's just go ahead and start simple. The GET request. Just get some data from a server. So let's go ahead and open up a new REPL. Now normally when you have a locally installed version of Python, you use a tool called pip to install software. But what's nice about REPL, I don't know when they added this feature, this is actually an amazingly intelligent feature, that for most of these external modules and libraries, if you just do import, it's smart enough to do it. Like if I imported, because I don't think requests is built in. I think it's a separate library. But if I just do import, and it's called requests, plural, and I run, it should automatically run and download it. Yeah, so I just did that in the background. So now we have that available. So if I want to do a GET request, I do requests, REQ, if I can spell it right, dot get, and then I pass it a URL. Well, they have something here. Let's stick to this JSON placeholder. So let's just get a resource. So let's take this and copy and paste it. By the way, we're going to do some copying and pasting, which I don't do often, so I'd suggest having this open off to the side. So if you go, it was under resources, we're going to have requests library open and JSON placeholder open. And we go ahead and run it. Something happened, but we don't know. So we don't know if it successfully ran or what happened. So we get back a response from that. Okay? So we grab it, and then we get a response. So let's say response is equal to that. And then let's just print response. Let's see what response is. Is it going to give us just the data? Is it going to give us the data plus headers? Is it going to give us data plus some other stuff? So it gave us, when you see these angle brackets in Python, it means that it's giving us some sort of representation. So, okay, so that's interesting. So it gave us some sort of representation. Now going back to this documentation here, the first thing that we see is, okay, we can get a status code. So let's do that. Instead of printing the response, let's try to get the status code. Now remember this notation. So most likely response is a what? It's probably an object, right? And then remember we did this in one of our other assignments. No. I'm just going to copy and paste just in case. Did anyone else's crash, or it was just mine?
Mine too.
Okay.
Mine worked.
I wonder if it was everyone all of a sudden hitting submit at the same time. It's all right. Oh, sorry, it wasn't status, it was status underscore code, right? Status code. Okay, and you can see 200. Now, I don't expect you to understand or know what 200 is, but I'll just let you know beforehand that many times we encode things in numbers. Okay. So if I want to get the actual content returned, great. So let me get that. See what that gives us. So that's interesting. It gave us some stuff back that kind of looks like a dictionary to me. But what do we see? What's the very first character? B. So anytime you see B at the beginning of a string, that means it's a string of bytes. It's not a string of characters. Now this gets into character encoding, which is kind of a complex. This isn't super useful to us. So we go down here, we say, okay, a string of bytes, but we don't want that. If we actually wanted the UTF encoded version, we can actually use another field here called text. And that's probably going to be more useful to us. And so before you switch it, I'm just going to say, okay,